Good afternoon, everyone. It's my first time here, so I will not be taking any difficult question. And for me, steel is not the enemy. And I think one of the mistakes we make sometimes, like pushing for GFRP, is that we are pushing on and hitting steel instead of trying to promote and make sure that more people use the material for its properties. It's not GFRP, and I'm not saying this because you're here, Salim. GFRP is not better. GFRP is just different. So the more we know about it, and the more we get testimonials, the more people will adopt it. But if we keep hitting the steel will fight back, and then we are fighting amongst ourselves instead of promoting something better. Okay, so I don't know who of you is familiar with Dextra, but been around for about 40 years. And the reason I'm saying that steel is not the enemy is also because we manufacture steel products, right? I mean, I would be lying if I wouldn't say so. So yes, we manufacture in China, we manufacture in India. And also one of the misconceptions is that products that are made in Asia are, low quality, you can trace them, you can trust them. That's not true. I mean, we all know now that in Asia, the level of automation in some factories is way beyond what you can find in North America. But vice versa, you find low quality products. So let's get those prejudices out of the way. Some of the figures about how many, this is, so I'm gonna push for, I will not be using imperial units during this presentation, and I hope that's okay. So I'll be talking about meters and about square meters and square kilometers. So this is 8 million linear meters of FRP produced in China, 3.4 million in India. That was for last year. So one of the mistakes, I think and we are guilty, as I mentioned this morning with Richard, is that when we initially promoted GFRP as Dextra, we promoted it as something that is temporary, can be cut, and can be disposed of fairly easy. And now we're trying to say that it's the best thing for bridges. So we have to adapt a little bit our dialogue. The reason is, so the first application, our application for GFRP was used in the tunneling industry. I don't know how many of you are familiar with the tunneling industry, but when a big machine goes into a station box or in or out, breaking it or breaking out, we're going through steel. That's not the way the machine was designed. So this was actually making people lose quite a bit of time on their project because they had to cut the reinforcement within the concrete before the tunneling machine could break out. So that's not something that is very practical. So in 1996, we promoted with the contractor, and again, we are all engineers, I'm an engineer, but this is not only an engineer, it's contractors, engineers, owners, and we all have to try to roll in the same direction. So this was the first time a soft tie was installed. Now, today, it's every tunnel project has a soft tie. So we're like, why aren't we using more GFRP? It's going to make its way through. So we just maybe have to be a bit more patient. We're here to push it harder. But in that case now, it's common practice. Okay, so this is just the way we did it originally, and we promoted, and again, I'm sorry it's not directly for slabs, but you'll get your slabs later, I promise. The other thing is that we are now using GFRP for additional geotechnical. In the geotechnical world, in mining, it's used very, very, very commonly, and now we have been using it also with tiebacks, which can be an issue in some cities to have steel strand staying in the ground for after the project is completed, and then a micro-tunneling machine arrives or a piling rig arrives, and then it's a disaster. And then the liability, and everyone starts pointing fingers at each other. So once again, GFRP can be used also for many different things. Okay, I'm going to be talking about slabs. So I am not a slab structural engineer. I got my master's 22 years ago, and I haven't calculated a slab in 22 years. So please, no difficult questions about that. But before that, okay, so we've seen a lot of comparison GFRP versus steel. So GFRP is not stronger than steel. GFRP has different properties. It has higher tensile strength, but we know that shear forces can be an issue. In seismic environment, we know that given its brittle and non-ductile properties, we cannot be using it there. But in terms of lifespan, as we have been discussing, and obviously we don't have 50 years of knowledge about how bridges would behave with GFRP reinforcement, but as the doctor was saying before, we have 25 years now of GFRP in Toronto in some of those bridges, and no major issue. So for an owner, this should be a no-brainer. If I have a structure that can last twice longer, then that means that my capex cost in 50 years is going to be 100% instead of being it in 100 years. So that's something to remember. In terms of cost, again, this is very generic. This is not valid in every country, especially today with the tariffs changing the cost of everything every day. But this is roughly an order of magnitude of how much you would pay for GFRP versus black steel versus stainless steel. We're going to be talking about a few of those other advantages. So this is a project in Saudi Arabia. We know that Saudi Arabia has been pushing a lot for GFRP application. So this is for 50 square kilometer park. That's huge for those of you who don't know what a square kilometer is. And there was different applications. So there were slabs that were outside, and there were slabs that were inside manufacturing sheds. But this is a very big push for the Kingdom of Saudi Arabia to get more and more tech companies, to get energy, to get greener, to get a lot of people coming, and they're building using GFRP for the reason I'm going to be highlighting later. So when we say about, we have to change is painful. So whenever we want to convince an owner, we usually have to convince about 9-10 people, depending on how many engineers are on the side, and it only takes one person to say no for things to go two ways. So we have to make sure that we talk the language of every different stakeholder to make sure they understand the advantages of the product, and not saying, it's greener. No, I mean, that's what is interesting for you, and how I'm going to push for it. So these were the different areas of the project. So most of the areas were within, like in warehouses, and so the loads were not that high, but there was a big area that was outside. The container stacking area where big forklift and a crane on rails would be installed. So originally the design was with epoxy coated rebar, grade 80, And you can see the loads applied to this slab. So this is, I don't know who Jim this morning was saying, is this a structural slab? Yes, so this is a structural slab. I'm going to be talking about what we did to convince the client. So the first time is that we were involved very early on with the owner to talk about how much would it cost the owner to maintain the project once the contractor is gone. And that's something that the contractor doesn't care about, or the engineer doesn't care about that much, but the owner cares about it a lot. So having this conversation very early on with the owner would pave the way for the owner to push the engineer, and the engineer to push the contractor or work with the contractor. So the owner is a key component of this, because this speaks to the owner. Like, in how many years would I have to maintain, and what type of maintenance would I have to do? In lead time, in that case, well, we produce also coupling to GFRP bars. As far as we know, there's been a lot of work and people trying to come up with a coupler for GFRP bars. Because we understand steel quite a bit, we think we have found a way. Actually, we've been using it. We swage a black steel coupler on the GFRP bar, and then we thread one bar with the other. So I'm going to have to take that phone whenever you do. I'm just kidding. So this product can be used instead. We developed this product for geotechnical anchors because this little coupler here can withstand about 25 tons of tensile strength, which is actually the limiting factor. With the swaging, we lose about 20% of the tensile strength capacity of the bar. But again, from the application we're talking about, it's plenty, because we know that the tensile strength of the GFRP is not usually the deciding factor. So this product can also be used in stage construction for bridges. If you have a bridge where you have 2 lanes on one side, 2 lanes on the other side, today you have to cut 2 lanes plus something. So traffic-wise, for the user, it's not the best experience. So yeah, so the application are multiple, similar to application for steel couplers. And again, we discussed about the dowel bars earlier. There was a comment about GFRP cannot be bent, which is one of the shoe that how do you say that when you have a rock in your shoe, right, and you can't walk. Yeah. Exactly. So, but the truth is, there's been a lot of progress today, and some resins around the world are being developed to be able to, like thermoplastic resins, where you can be able to bend the bar once you have it. So it is very still in the technology. It takes a long time, but in case of emergency, I mean, this will continue to evolve, and tomorrow it will be faster, cheaper to bend GFRP bars, which will take one of the rocks in our shoes in what we do today. And we'll also involve the rebar fabricator, which today is not involved at all in the cutting and bending because it's done at the fabricator. So we can understand that the steel people can say, I don't want to use, what I'm going to do with all my people, like to cut and bend rebar. So if they can cut and bend GFRP, maybe we'll have them on board as well. Okay, GFRP though we discussed that at length this morning. I'm not going to go over it, but it's another one of the applications. Okay, carbon footprint. This is a lie. Okay, I just want to say before I get questions. The first thing is, how is the steel produced? If it's recycled steel, it's 6 times less carbon footprint for production per, again, you talk about ton or do you talk about equivalent tensile strength? So there's a lot of talks in there. GFRP is greener. No, GFRP is not greener. It depends what you compare it with. So again, compared to recycled steel, it's not. However, and that's something that is a big thing. If you add up the cost of transportation, again, comparing 2 bars that have similar properties, without going into too much detail. But the added cost of shipping, because of the weight of the rebar, can make a difference, even with recycled steel. In that case, we are like this one, if you include the scope 2 emissions. And I encourage all of you also to publish your EPDs. So all our EPDs, I don't know if everyone in the room has the EPDs, but this also goes a long way in terms of transparency, in terms of showing that we are